Hello everyone, welcome back to the sessions on DBMS. Today we are going to learn about transaction concept. What is a transaction? It's basically a set of operations used to perform a logical unit of work, the unit of program execution that accesses all possibly updates the various data items. Now, when I talk about this transaction, it can be regarded as a series of reads and writes of database object. When I say a database object, it is the unit of program that is read or written information. That is, the units could be the pages, records of the tables, etc. Now, what is this all about? Why do I say that it is a series of read and write? Don't we have other operations? Yes, we do have. Say for simple example, when I say transaction, what comes into your mind is the money transaction. That is, you are transferring money from one account to the other. Say for example, in account A, I have got 1000 rupees and I want to transfer 500 to account B. So, what am I doing? I am reading the value of A, subtracting 500 from it, okay, and then I am going to transfer that amount to B. That means read the value of B, okay, and add 500 to that. B equal to B plus 500. Now, these arithmetic operators in between are the intermediary actions, but what is mainly affecting the database is the read and write operation. Here I will write it back and here also I will write it back. So, this is the series of read and write operations that we are performing. Okay? So, to read a database object, first you need to bring it into the primary memory. In operating systems also you have learned this concept that any program for execution has to be brought to the RAM first, right? So, from the storage location, here also the data from the database which is in the server maybe, you have to first bring it to the main memory of the local system. From the disk it has to be read and its value will be copied into a program variable. So, when I say read A to a temporary program variable from the stored location, I am reading it. So, this is the read operation. Similarly, when I say write, you make the modification to the local copy of that data first and then write it into the database. So, basically I can say transaction is a series of read and write operations. Now, what is very important when I talk about a transaction is it needs to be consistent in the database. That means before starting a particular operation, whatever is the value, the say sum of that. Now, for example, which I took, like for you are transferring the data from one account to the other. The total balance of account A and account B is some X. If it is before transaction, if it is X, even after the transaction it should be that same X. The values in A and B may vary, but the sum total should be same. So, that is what is consistent. During the execution of the transaction, it may be inconsistent. Now, for example, when I changed A value from 100,000 to minus 500, A became 500, but B was maybe somewhere around 2000 still. But when I complete, the total of A and B will be as before you started the transaction. That is very important. Now, the situations that we have to deal with is there may be failures of different kinds while you are transacting, that is while the transaction is happening, there may be different kind of failures. Failures like suddenly there may not be, you lose power supply, or maybe system crashes, or maybe you are supposed to read from a location where the disk is corrupted. Something like this, there may be certain failures, or there may be concurrent execution, that is multiple transactioning happening at the same time. So, I need to take care that the data updations does not affect. We will come to those points later, but remember there are certain issues that has to be considered when I am talking about the transaction. One is ensuring that the data is always consistent. Now, in order to do this, there are 4 different types of properties that has to be considered. As a database user or as a database programmer, you should make sure that your transactions or otherwise your design of the database should ensure these properties, which we in general call as ACID properties. It's an acronym for atomicity, consistency, isolation and durability. Now, what is this all about? Remember, these DBMS has to ensure that these 4 properties will hold to maintain the data in phase with the concurrent access and system failures, as well as to maintain the integrity of the data. Okay? Now, what is this all about? The first one is atomicity. What do you mean by atomicity? Atomic, one single unit. It says that user should be able to regard the execution of each transaction as atomic. In simple, it says either all actions or none. Now, what does it mean? Now, say for example, in our previous example, I just took it as a read of A, then we are saying A equal to A minus 500, then we are saying write of A. Similarly, continuation would be read of B, B equal to B plus 500, then I am saying write of B. After all these things, there is something called as a commit which will make these changes permanent. Because remember one thing, when I am doing the transactions, whatever updations you are making is not permanent unless and until there is a commit which is executed which makes the changes permanent. This is all temporarily maintained. The reason is because I have to ensure this ACID properties. Now here, because of this particular thing, at any moment before this commit, if the transaction fails in the sense, maybe you have updated A by subtracting 500, but you could not read the value of B due to some system failure or any of the changes. Now, what happens is, say for example, earlier in A's account there was 1000 rupees and in B's account there was 2000 rupees. The sum total is 3000, but if at all you are going to make this changes, the A's value is subtracted, that means 500 reduced. Whereas this I could not perform. So, B value is still 2000. 2500 is the sum total which is inconsistent. That is why the ACID property ensures that the atomicity property ensures that either you do it all or you don't do it anything. If it is halfway through, then cancel all the performed transaction. That means you have done up to this and it failed, or otherwise you have done up to this and it failed before committing, then you have to cancel everything. That is what is the atomicity property says, either all actions or none. Either all the operations of the transactions are properly reflected in the database or nothing. This is what is atomicity. Because so that I can ensure that the data is consistent. If you are not able to perform everything, then cancel. Okay, do it from the beginning. The consistency says each transaction run by itself with no concurrent execution of other transactions must preserve the consistency of the database. As you know, as we said, whatever the state the database was in before starting of the transaction, you should ensure that it will be in the same state after execution of the transaction. Now, consistency ensures that you may be simultaneously working, you may be working one after the other, no issue. But the data should be consistent everywhere after or before that particular transaction. So, execution of the transaction in isolation preserves the consistency. So, what is isolation? We will try to see. Coming to this isolation, although multiple transactions may execute concurrently, because basic advantages of DBMS, we said they are running parallelly, you allow concurrent execution. In spite of that, each transaction must be unaware of the other concurrently executing transactions, even if the DBMS interleaves the actions. It may so happen, what you saw in the previous one also, it may so happen that there may be reading of A may happen, then before subtracting this, reading of B may happen, then you subtract this, then you write A, then you add or modify B. It may happen interleaved, but the assumption, the idea of isolation, wherever you are modifying the common data, it has to ensure that there is a lock which is applied, and it has to see to that other executions will not interfere its execution. But in case of regular where the data is not affected, in such situations you will see to that they are done in such a way that you are having a feeling as if the set of operations, or if there are two transactions T1 and T2, though they are executed in an interleaved fashion also, the effect would be such that you are executing T1 as a whole followed by T2, or T2 as a whole followed by T1. So, it says for every pair of transactions Ti and Tj, it appears Ti that either Tj finished execution before Ti started, or Tj started execution after Ti. That means we are talking about a concept of serializability, because serial transaction can ensure consistency. So, we are, of course, there is a topic on this, view serializability, conflict serializability. We will discuss about it in the later course of time in the PDFs here, I mean in the presentations here. But remember, isolation basically talks about running them as a single set of values. Then finally, coming to durability. After a transaction completes successfully, remember when I say complete successfully, there is a commit which is executed. So, after it has been committed, the changes that have been made will persist in the database and they cannot be changed or otherwise lost even if the system fails. This is the meaning of durability. Okay, once you have committed, successfully completed, that is available forever. This is all about the acid properties. Now, let us try to see the implementation of the acid properties quickly, as I was discussing about it with you earlier also. I can quickly go through this. Look at the transaction. It may be I am saying I am transferring $50 from account A to account B. The series of action, as we said, read from the database, read the value of balance of account A into a local variable, perform the arithmetic operation in the ALU, and then update it into the data local program variable A. Similarly, read it from B and then update it by increasing, because you have deducted from here and you are increasing here, and write it back. Now, the consistency requirement says before starting this transaction, whatever is the total balance of A plus B should be same even after you complete. Even after you complete the transaction, it should be not changing. That is 1000 and 2000 if you assume. Total is 3000 before transaction. So, A's balance is 1000, B's balance is 2000. When I complete, A's balance would have been 950 and B's balance would have been 2050. So, but still the total is going to be 3000. That is what is the meaning of consistency. Atomicity requirement, see if the transaction fails after step 3 or before step 6, the system should ensure that its updates are not reflected. See, up to this I had written, okay. So, this value already became 950, okay, and then before I could do all these things, it gets failed in some way. Now, what happens? 950 and 2000, it is going to be $50 less. The total consistency is not maintained, inconsistency. So, I should ensure that I will abort this also, I will undo, I will cancel these 3 actions also. I have completed 6 also, but what happened? I did not commit it. That means I did not make the changes permanent. They are temporary. So still in that case, I should restart. I should abort this. Remember that that is what is atomicity, which says either you do all or you do none. Okay? Because if you don't ensure that, database will be in an inconsistent state. Durability, this is once the user has been notified that the transaction has completed, he will commit it, and once it is updated by the transactions in the database, you will not see the data to be, the data will be persistent in the database, you will not lose it. Isolation requirement, if between steps 3 and 6, another transaction is allowed to access the partially updated data, it will see an inconsistent database. So, in such situation, with the data transaction whatever, say for example, when I was transferring, before I could update B, I have read the A value which is already 50 minus. So, if you allow such things, the database will be in an inconsistent state. So, you have to see to that when you are performing that transaction, nobody else is allowed to interfere. The common data, that is what is the isolation, which I told you. We will be learning about the lock concept and all later. So, remember, so this is basically, okay, you are running the transaction serially, all these things are the implementation. We will quickly look into what are the different states of transaction. When I say a transaction, it can be in any of these 5 states, or otherwise finally when you complete the 6th state is called as termination. Okay, active, partially committed, committed, failed or aborted. What is this? An active state is the initialization of the transaction. When I start the transaction, initial state, in this state while it is executing, as long as it is executing, I say that it is in an active state. That means you have started reading the data into the main memory or the so-called RAM from your hard disk or server, wherever it is. Next, partially committed. So, when I speak about these transactions, these are the transactions that are happening. So, as long as the 7th state which says commit is completed, the database is going to be in a partially committed state. The transaction is in a partially committed state. That means I have not made the changes permanent. Now, during this partially committed state, before the final commit, at any moment the active transaction may come into a failed state due to various reasons which we earlier discussed, system crash or otherwise power failure or hard disk like disk failure, whatever it is, it may come to a failed state. Remember, when a transaction is into a failed state, it has to be aborted and restarted because of the atomicity property. For doing all these things, there will be a log which is maintained. Each action of the transaction is written into a log, whatever changes you are making, so that at a failed state, it can abort and get back to the original state before starting the transaction and restart it again to ensure that the asset properties are maintained, the database in a consistent state. Just keep that in mind. And after partially committed, if it doesn't fail, it goes into a committed state where I am making the changes permanent to the database so that it is durable. I won't be able to change it. I will not lose the data anymore. And finally, after this, it is in the terminated state, which can also be discussed. Terminated state is all the resources that you have used, you will release. You have learnt it already in the operating system also. For executing any particular action or any particular program, we need certain resources. Resources like the memory that you have used, the CPU cycle that you have used, all these things will be released so that the next transaction or next program can execute. So, this is all about the various states of transaction. In our next session, we will discuss about a transaction schedule. What is a schedule and how do I execute the transaction concurrently? Thank you.